Thank you, Tom. And as I said before, really happy to have you on board. You've already been helping us with the use cases, and we are really looking forward to Sato-san and you really taking this forward. So I'd like to now give the presentation rights to Sato-san.
Hello, I'm Yoji Sato. I work for NTT Communications, and I also work for Okinawa Open Laboratory, and NTT Com recently released open source based project in the commercial facility using SDN, so-called AP Gateway project. It is used Ryu as a SDN controller and using OpenFlow switch as a gateway. So using SDN, open source software is much important. So ONOS project is also important for the carrier to develop SDN to the wide area network. So I'm very exciting about to join the ONOS project. And yeah, that's all.
Great. Thank you, Sato-san. And I did want to mention that it's actually about 2 a.m. in Japan time, and Sato-san actually woke up. He had a person actually call him so he could wake up in time for the meeting. So, I mean, with this, I'm sure our use cases will go a long, long way. So thank you very much for waking up in the middle of, like, literally the middle of the night.
Yeah, actually the 3 o'clock morning.
Yes, I'm really sorry about that, but thank you very much. Thank you so much.
Yeah, but I can wake up by myself.
Thank you so much again. So having said that, what I wanted to do now is 2 things. Because we've got 4 minutes, I wanted to take a quick detour and show you a few things. Let me go to my screen. Am I presenting this?
No.
Okay.
You have the right.
Yeah, okay, sounds good. So quickly, I wanted to show you that we have, all of you are familiar with the wiki. And in the wiki, essentially, if you go, okay, let me make sure. Sorry.
You don't need to log in.
Can I go to the spaces?
Yeah, you can see it. You can see it.
Okay. Thank you. Okay. Maybe I'll let the people who are technically more adept get started. And I promised to show you the wiki. So essentially, we just 2 things I wanted to mention. There is a wiki page that we put together for each of the steering teams. So the use cases steering team has its own page. On the page, you have essentially the folks who are driving the use cases steering team. There is also a way to contact them and the team as well and send in your suggestions or any other things you'd like to see. And then there's also a way for you to essentially put in proposals for new use cases. And then the last thing which I also want to mention is that now we are going to start having recurring meetings for each of the steering teams. And the use cases steering team will have a meeting on the first Friday of each month from 10 a.m. to 11 a.m. Pacific Standard Time. So you can find all these details on the steering team pages, and I'll shortly just show them to you once we are done with the planning session. So having said that, let me start with the planning session. We've split them up into two parts. So there's a part 1 and a part 2. The part 1 is essentially all the use cases that were driven completely out of here, and they were also shipped out. At least the phase 1 of them was shipped out with the release that went out in December, which was Avocet. The part 2 is essentially the newer use cases that came in, and all of these came in from the community itself. And so we wanted to sort of highlight the breadth of the use cases we are tackling as well. And then we'd love for you to bring in your use cases so we can just work them into essentially the roadmap. So with that, let me start with the part 1 of the use cases, and let me start with Mark.
Hi, so good morning. This is Mark from Open Networking Lab. Projecta is pulling up my slides, but so as she mentioned, this is a use case, the IP optical, that has been going on for a little while now. It is one of the use cases that is getting a lot of attention. Almost all of our partners get very excited when we talk about this use case. So we want to make sure that we get things right and we do the right thing at the right time.
You can move this. You can take this.
What?
Take this.
Sure. So just to set the stage here, what is the goal, the overall objective of this use case? We want to build an operating system that can handle everything that is necessary to run a multi-layer network, right? And fully in line with ONOS' main objective is that we want to do this while offering scale out and high availability and high performance. So we've already built some of the tools and some of the functionality inside of ONOS, and we demonstrated that in December last, where we essentially showed you how layer 0 and layer 3 bandwidth provisioning and restoration works in ONOS. This was running in a fully software emulated environment using Mininet, Link-OE, and Open vSwitch. And we based everything on OpenFlow. Some of the missing features, at least that's what we believe are missing, is that we did not show that this can really work on hardware. And a lot of people are telling us this is critical if we want to be accepted in the community of being a potential target to develop against. And the second one is we didn't really demonstrate how this thing scales. There's a lot of work inside of the ONOS core to show high performance and to show scale out. But we haven't really demonstrated it inside of the IP optical use case. So having said that, I reached out to many partners and we talked a lot and tried to come up with a plan for the next few months. And this is basically what we came up with. There's two epics, two main branches, main dimensions along which we want to work. One is we want to build a proof of concept. Proof of concept will essentially be a hardware testbed consisting of multiple layers, just like the use case prescribes, and preferably multi-vendor. So we reached out to a couple of vendors, and we have, I would say, a soft confirmation for now from Sienna and Fujitsu to get the layer 0 equipment, and as well as a confirmation from Corset to provide us with packet switching, so we can build a multi-layer network. There's one critical element here for now that we haven't tackled yet is if we want to talk to ROADMs, we're going to have to speak TL1. In one way, on the one hand, ONOS is really about innovative services, and whereas TL1 is really a historic or traditional way of talking to switch. But there's probably no other way around this problem, so we will have to support TL1 protocol. This proof of concept will essentially, in broad terms, do this more or less the same thing as what we've shown in an emulated environment. So we'll show bandwidth provisioning and restoration. That's at least our initial target. Second is we want to take this emulated environment much further than it is today. We believe that what we've learned from Mininet is that we can build based on these pieces, an open source reference platform for multi-layer networks. Obviously, this is super useful for prototyping, for evaluation of your new algorithms or your new protocols. This can be used to validate certain new developments. One example of this is we reached out to the Optical Transport Working Group in ONF, and they talked to us about validating their work on OpenFlow Layer 0 discovery protocols. Besides these high-level objectives, this can also really be used as a platform to demonstrate scale NHA for our packet or IP optical application. But it's going to require a lot more integration between Link, which was built by Infoblox, and the way Mininet has been doing things if we want to achieve a really dynamic software network environment. Prajakta also asked me, besides what we fully commit to realizing, to get a few bullets out of where we want to reach out to the community, to our partners, in helping us achieve our goals. And here's a few that I believe that we can definitely use your help, and we're very eager to get things going. One of them is external PC. So talking to almost all vendors, they came with the same message. We have a lot of intellectual property built into that PC that we all have our own, and yet we do want to use this thing in a network. So at some point we're gonna have to support external PC as a service that ONOS can use to do path computation. Probably this means implementing PC protocol and adjusting some of the related data structures in ONOS. But I mean, we're open to all discussions here. Another one is, so far ONOS we've shown restoration, bandwidth restoration, which is I believe essential if you want to be successful in the IP optical space. But we should take this much further. There's a lot more we can do there. Not just restoration, but we should think about what kind of protection techniques we should build in. Whether we should go through the controller when things fail, or should we have some kind of automated protection switching built in. There's a lot of potential directions we can go in there, and we reach out to the community to help us build that. Second epic is, so as I mentioned, the emulated environment can be used to validate neighbor discovery. There's already a lot of work, a lot of standards processes going on in the ONF, and it would be great to demonstrate that this really works in an environment that reflects reality. Another point that was brought up often was OTN layer. Some people would argue, yes, you cannot run an optical network without an OTN layer. Others would say, hey, now that we have an SDN style controller, we can do the mapping between the IP and the optical right there. We don't need an OTN layer anymore. We'll let the community decide on that and reach out to them for helping us build that. Another one is making that emulated environment much more realistic and much more in line with what's happening in the real world, and by modeling physical impairments. And as such, you can you'll know, you have a much better view of what's going on at the lowest layers of your network. Some related information. So if you want to reach out, and we strongly urge you to do that, you can either contact me, I'm with ON.Lab, or Tom Tofik, with whom I'm working very often. He's from AT&T, but he spends all his time here at Open Networking Lab. And then I in the presentation, there's a few links for you if you want to learn more or provide us with some documentation. You can go to the wiki or the Google Drive. And if you want to really track on a day-to-day basis what's going on, we'll refer you to the JIRA, where you see all the issues and all the tickets that are being created and being handled. Prajakta, is there time for questions?
Yes. So in fact, you have about 13 minutes for questions. So if you so we are opening it up to questions. We have another like 13 minutes. We'll go on with questions till 10:40 for this use case. So feel free to. You want to pull the chat up? So if somebody.
Sure.
Yeah.
Where's it?
Just pull. Yeah, just pull it. So any questions from the community?
Yeah, I have a question. This is Min Hee from Fujitsu.
And just one quick note. Yeah, it would be good if you introduce yourself so the ONOS community gets to know as well. Thank you.
Okay. Yeah. So you hear me okay, right? Yeah.
Yes.
Just I have one question about the the community, the vendor PC extension. Do you envision the vendor PCE is running outside of the Carafe container, or is it inside the container?
We envision it to run outside, but if you have good reasons to run it inside, we'll gladly talk to you.
Okay, because I worry about the performance if it is outside.
Sure. I mean, yeah, we can start trying it out and see how far we can go by doing it outside. But yeah, like you said, if there's a good reason, like performance is a very good reason, then we'll work with you to bring that inside of ONOS for sure.
Okay.
Can I make a suggestion?
Okay. Yeah, this is.
Thomas, go ahead.
My suggestion would be to integrate it as a path service or an extension to a path service, and whether the implementation runs inside or outside is completely irrelevant. But on the inside, it needs to be made available as essentially as a service. Whether it uses some sort of a standard protocol or whatever custom mechanism, it's entirely irrelevant. We need to be sure we don't bring back a dependency on protocols.
Oh yeah, okay. But when you say service, you mean the like a bundle service if it's inside.
Yeah, we have a path. There is a path service, admittedly with a somewhat naive interface. But my suggestion would be to extend that interface if necessary, but expose it as a path service on the inside. However, that information is then attained on the inside, it doesn't really matter.
Yeah, I agree. Okay.
I have a comment, maybe a question also.
Introduce
so this is Tom Tofik from AT&T. So I'm just wondering if, from community's perspective, how important is OTN layer? I guess my preference is not to give OTN layer, a priority. If we can show that packet over layers lambda, layer 0 can work first, and if it's definitely necessary, then we can go to that step. But just want to get to the top on that.
Min, would you like to comment on that, or anybody else?
Yeah.
Who's
Excuse me. Yeah, I could comment on that. The problem with the layer 0 is very inflexible, and a lot of time require manual intervention. So all those dynamics and fast calculation. By the end of the day, if a manual intervention is required, it doesn't serve too much purpose. So that's why if you have an OTN layer which is non-blocking, and then you can show more benefit of the SDN environment. So I think it is possible you directly IP go over the WDN, but the reality really take advantage of SDN. In my opinion, is OTN probably will give you more benefit using SDN, that kind of architecture.
I also believe that some vendors make note of the OEM features OTN gives. So operations, I forgot what A stands for, and monitoring, which is badly standardized or worse, less standardized in WDM layers versus better standardized in OTN layers. And so there's a lot of benefits from working with standards in these kinds of environments. But again, I believe this is something the vendor should weigh in if it's really necessary, because it's a lot of work if we want to tackle
Yeah,
this problem.
yeah. And another thing is if we target like next generation rodent, like a CDCG rodent, or also try to make it work with a traditional classic rodent architecture, which is even the classic one is not very, very flexible. The next generation one a little bit more flexible, but the price is higher.
Right.
Yeah. But just no matter what, compare with OTN, definitely OTN is a lot more flexible. Okay.
Any other questions?
You are indicating to TL1 southbound, right? The TL1 kind of protocol or something?
Correct.
Yes.
So, you want to?
Yeah. So the question was, what is TL1? So TL1 is the way vendors have traditionally spoken to their rodents, to their layer 0 equipment. So it's a protocol. The problem with it, it's not the protocol itself is standardized, but the fields and the values and the data models inside the protocol can be customized, and they all did that. They all have their own TL1 implementation. So we can't just add one TL1 and we're done. No, we need to speak specifically to a Sienna box or a Fujitsu box or a different kind of box. So it's a tricky situation to be.
Maybe in talking to Sienna, Fujitsu, and others to see if we can find at least a common ground of these plans that we can at least open source it, you know, with Linkoe as support and
One quick question. This is Patrick. So the question is for the real hardware rodent. You will see you are using the Fujitsu's and Sienna.
We hope.
All these are rodent or open flow based.
I believe they are not.
Okay. If not, I have another question. It's basically in current IP plus optical models with surface model and underneath models, we based on the open flows, W port and T port, all the things. So what's the purpose to try this, the non-open flow rodents in current architectures?
So we're wide open to getting open flow based rodents. Problem is no one has them, or they don't like fully support them yet. That is the core problem.
I'm seeing a lot of conversions and the remapping from this traditional the legacy rodent to the open flow one. So it's a lot of work. So how do you solve this one? So I see the workload in the EPIC.
So is there a question?
Yeah, I think
has a rodent with an open flow maybe that you guys.
Correct. So I think what we are trying to, and I'll probably just add to what Mark said. So what we are trying to do with this use case is actually threefold, right? So for us, the first thing we started with is open flow. And what we created is this optical emulator called Linkoe with the Infoblox folks, right? So the idea is as slowly as the standard progresses towards supporting more and more of the functionality, there will be boxes that come out that support that functionality, and you're able to do most of the tasks using that functionality, right? So that is the forward-thinking piece of it. At the same time, to vet out our data models and everything that goes on the top, so such as the multi-layer modeling, the PC, and so on. What we also want to do is add in some hardware boxes in the mix. And that is where this TL1 plugin is coming in the picture, because this is something we want to do right now. And then the third part is as even vendor boxes, open source, any type of box with open flow comes about and can provide a good set of capabilities, we're happy to fold it into the use case. So it's like, you know, go all out on all fronts, because what the value we provide with ONOS is on the top, right? And then the idea is to just flesh it out with all of these.
Okay.
So any other questions? Otherwise, we'll move on to the next use case.
Can I have a last one, a quick one?
Sure.
But probably we do not need a full answer today. It's just
Sure.
one area ONOS is not currently defined, very clearly defined, is the data modeling. For example, how do we, let's say, for the rodent network, how do we, define those network in what kind of data structure. ODL, they have a YANG modeling. That's the way they choose to do. But ONOS, we do not have any specific one. Currently, in the first release, we have a few very simple case like device and a few little things. But just moving forward, and how do we do the modeling? I don't know, the technical engineering committee have any good suggestion how do we do it? Because that area probably likely need to be agree among the multiple vendors, so and we could all store our information in a certain form and format.
Thomas, see, Thomas, if you're dialed in, you've got 2 minutes to answer this question.
Yes. Well, I think this would be an ideal subject for one of the technical steering team meetings. We're in the middle of scheduling the recurring meetings, which will most likely be either every 3 weeks or every 4 weeks. And so this would be an ideal topic for discussion of that.
Sounds great.
Okay.
Min, is that okay? Would that
Yeah. I know that's not the simple answer here. It's need a lot of discussion. Yeah, definitely.
Correct. In fact, there is tons of discussion going on different aspects of this. So yeah, like Thomas mentioned, the meeting is the place to go. So with that, let's move on to the next use case.
Hi everyone, this is Luca for the Internet 2 and SDN-IP use cases. Well, first of all, you can find here my email in case also offline later on you want to know something more, or of course feel free to write to the mailing list we have on our wiki. So let me resume what we want to do in this use case that is basically driven now by the deployment of ONOS on Internet 2 AL2S networks. So the purpose of this deployment is to connect six universities spread around the country together. So to give them IP connectivity, all-to-all IP connectivity through an SDN network. So each university is going to expose a legacy, let's call it legacy, so I mean not SDN, a classical network, layer 3 network, and it's going to announce a /24 subnet to the other universities. All these networks will be announced to a transit network, core network, controlled by ONOS and a specific application called SDN-IP. Universities and the transit network will talk together thanks to BGP. And then it will be up to the SDN-IP application and ONOS to translate the BGP announcement into ONOS intent request, and then in OpenFlow entries on the switches, thus enabling the communication between the different networks. Okay? So said that, let's see quickly. I don't want to go too deep in the details, but just to give you quick numbers, we said 6 universities. We have 43 switches in the core. So I guess the cool thing of this deployment is to provide layer 3 connectivity without using expensive, I would say, routers in the core. So just the universities will use common routers to announce their networks, but on our side, of course, no routers, just as SDN switches. Of course, the deployments will take with it all the benefits of coming from SDN, plus the ones added by ONOS, so scale out, performances, and so on. And as I said, SDN-IP application will exchange the routes with the external islands and will translate them, the advertisement into intent requests. Okay. So this is possible thanks to SDN-IP, which is an ONOS application that allows you basically to scale and connect to the rest of the internet, migrate, of course, your existing networks to SDN more incrementally and smoothly, I would say. Since we can talk basically through standard BGP with any existing network. For now, SDN-IP implements HA functionalities. It does not include the both for what regards to the data plane and the control plane. Load distribution is not there, but hopefully we will have it soon. So here is the actual progress. It seems from the first test that SDN-IP is pretty stable, which is quite good to be in a first release. Of course, there's lots of work to do. There are the integration tests. Some of them are there, some of them are not. Of course, this is not what we want. So this is considered a priority, especially because we need to do a deployment, right? So I believe that integration tests are kind of a basic thing if we want to deploy it properly. So there's a collaboration, of course, to make this deployment happening. There's a active collaboration with the Internet to NOC. And the idea here is that basically we have two deployments. The first one is to validate our software, and is happening now on a test lab, a remote test lab run by Internet 2. And basically we are installing ONOS and all the things we need there. Once we have that, which is almost done, and I'm going to tell you in a minute why almost. When it's done, they will validate our software, and at that point, we will be able to plan the real deployment. That at that point should be quite straightforward. So the issue here, which is blocking now, is that a vendor, a switch, is not supporting the rewrite of the destination MAC address, which, as you may understand, for a routing application is a quite basic feature, right? So we are trying to do some tricks to avoid it. Of course, we ask also to the specific vendor to support us in the future and to introduce this feature. So I think it's a good occasion also for the vendor to insert it in his feature set. So the very first thing we are doing now is to understand the real feasibility of the deployment for this issue. Then we will validate the software, and then we will go, if all this happen, to the real deployment on the AL2S network, which is the production network of Internet 2. For this deployment, as you saw, we are talking about 6 universities announcing one route, right? Actually, SDN-IP is able to support 20,000 routes, and we are getting better and better in the next future. So the deployment, in this specific deployment, the performances are not an issue. Of course, we want to be performant if it's possible, but it's not a must-have requirement. Okay, so here I started to track in these slides the list of main epics and stories we have. So this is, let's say, if everything moves forward as expected with Internet 2, these are the must-have for February release, right? You can find in Jira under ONOS 493 all the epic regarding Internet 2. Basically, it's divided in 2 big stories, which are the deployment on the local testbed and the official deployment, okay? And please go there and have a look at all the stories we have. You'll find for sure many more details inside of those and detailed tasks. Okay, so, but basically it's what I described you in the previous slide. So on the other side, we have some desired features that we want to strongly have. And here is where I see more the involvement, the help from the community. Are not must-have for sure for February, so maybe is a little bit too much, a longer plan, but let's go through it. So as I told you, we want for sure to improve the performances of SDN-IP. So if we consider internet today, more or less the BGP tables are around 600,000 routes, and these are the numbers we would like to match, even in the optics looking forward to the next deployments, right? That hopefully would be even bigger. So to do this, I put this in by May because, of course, this depends also not just by SDN-IP itself, but also by the performances provided by ONOS itself, right? So it's not just SDN-IP, but it's all the stack to tilt to the southbound that we need to review, okay? So then we need to understand the network modeling and do a kind of configuration refactoring. So basically it means that today, unfortunately, you can configure SDN-IP, but it's not so straightforward and so easy to go through the configuration. I wouldn't say it's impossible, of course, but you need lots of effort to understand how does it work, right? And this maybe, I guess, is because when we architected all this, it wasn't so clear in our mind from the beginning what to do, how to do it. Now, possibly we know something more. we know something more, and so I guess we can re-architect all the configuration for SDN-IP and not only SDN-IP. There's a discussion going on, and we would like to extend maybe the configuration to more applications. So create a unique configuration system for the entire ONOS platform, okay? Because this requirement is not coming only from us. Then we have some security issues to solve. For example, right now, SDN-IP is accepting any BGP session that is going to it. We don't want this in a deployment, I guess, right? So this means that anyone who speaks BGP can possibly connect to SDN-IP and say, hey, these are my routes. And of course, this would change the behavior of our network. So we need to enforce some security things. We need to finish to integrate IPv6. There's a fantastic work done that is going on, done by Pavlin and other guys. Oh, sorry. Oh, sorry about that. And so anyway, there's lots of issue and issue. So and Charles. Charles, is it you that is complaining? Sorry. So anyway, there's a big effort going on, and we are at a good point. We just missed a few unit tests that we need to integrate in this work. There are other security issues, like on link discovery on the external access ports, and other deeper things. I mean, I don't want to go too deeper in the last 2 points. You can go for sure in Jira. I guess are quite easy tasks, like changing the southbound API of SDN-IP for communicating with ONOS. And that's why I put in red those voices, because I think are some tasks that also external user can take and do on their own. Just reading the code, having our suggestions. So I think are nice stories that an entry-level user also can start to work on. Okay, so that's it on my side. Of course, if you have any question, feel free to ask now or send also emails offline. Let's see.
Pull this up. Luca, you can see it here.
Yes. The answer to the data question is yes.
Just read out the question.
Yeah, so David Bainbridge asked, intent replace, is that code for modify? Yes, basically yes. If something change, what we do now is delete and add again an intent. Instead, there's an API that say directly replace this intent.
So for a number of reasons, the intent this is Brian from ON.Lab. For a number of reasons, the intent objects are immutable. so you can't modify the fields of an object once it's been created. However, if the application's request changes, they need to construct a new object, and replace is just taking the old object and replacing it with the new, hopefully reusing resources and not disrupting connectivity.
Yeah. Okay. Thanks.
Yeah,
the word replace has some semantics built into it that are different than modify. I just wanted to make sure that reuse, preserve connectivity was kind of captured in that. All right. Thanks.
Right. Yeah. I mean, maybe. Yeah, I agree. Replace probably isn't the best word. Modify may be a better word, but modify sort of implies mutability. So yeah, perhaps we need to rename the function, but yeah, the idea was to preserve connectivity when possible, and minimize the disruption of the data plane.
Yep. All right. Thank you.
Yep.
Any other questions?
So I think if any of you are from the service provider space and are looking at migration strategy, this would be a good use case to look at. And you should ping Luca, and Luca has his contact information in the beginning.
Yeah.
So feel free to ping him, because this Internet to deployment, and we're also doing some other deployments, and it would be a good idea to get what exactly they're doing and then how exactly they're transitioning to SDN. So feel free to ping him as well.
Oh, I have another question. Thank you. How do you see actual deployment with geographically apart switches? I don't know if I don't know if I understood correctly the question, but basically you are telling me if it's going to be a problem if the switches are geographically distributed. Is it a yes?
I think he might be on mute.
Okay, so if that's the case, yeah, okay. Anyway, if that's the case, and I interpreted correctly your question, the answer is that we shouldn't have problem. ONOS was created basically for that, for at least we plan to have a geographically distributed deployment, right? At least on the data plane. And so, of course, as long as we provision things correctly, for now, the bottleneck also for rerouting the intents and everything was just in BGP and in the timers. So when a connection went down, for now, the problem was just to wait for BGP and not for the communication between the control plane and the data plane on the SDN side. So, yeah, I guess we shouldn't worry too much for that. It should be fine. Of course, we will see in practice what will happen with the real deployment, right?
Okay. There's one coming, right? We haven't talked about network functions.
You're talking about this question?
For that question?
Correct. Yeah, so I think we got one question that was not exactly related to this use case, but it was talking about data center use cases. So one of the ones we'll be talking about is essentially network function as a service, and then you'll see that soon, just about one presentation after this. So any other questions? If not, we will move on to the next use case.
Thanks, everyone.
Hey.
Good morning to everyone. I'm Srikanth from Ericsson, and today I'm going to talk about segment routing use case on ONOS. And its current status and goals for the cardinal release. As many of you are aware, this use case has been started in collaboration with the ONS, and currently the team is composed of Shango from Samsung and myself from Ericsson and Saurav Das from ONS. Okay, to the benefit of those who are new to this use case, I'll quickly provide a an overview of this. The main goal of this use case is to demonstrate SDN-based control of wide area network using segment routing principles. Segment routing is relatively new technology being standardized in IETF Spring Working Group, where Spring stands for Source Packet Routing in Networking. And segment routing leverages the source routing paradigms and globally significant labels. And it can be used on the existing MPLS data planes or native IPv6 data planes. But for this use case, we have chosen the first one, that is MPLS data plane, where with no changes to the forwarding plane and without needing for any complex label distribution protocols like LDP and RSVP-TE. So in this use case, ONOS provides the segment routing service, which is responsible for building the segment routing forwarding tables and imposing the segment routing label stack. And the open segment routers have been built by Dell on their 4810 open networking switch that supports OpenFlow 1.3 and Spring Open hardware abstraction pipeline. So for more details, you can go over the wiki where we have captured this use case in detail. So for now, I'll move on to the next slide, where we capture the current status. So as part of the last month open source release, we have demonstrated segment routing use case on a development version of ONOS with Dell open networking switches hardware. We demonstrated two networking scenarios like default TCMP routing and recovery and policy-based traffic engineering case where explicit routing scenario is demonstrated there. Again, this is the link where you can find more details and demos of the last release. And coming to the goals for the cardinal release, that is the May release. So these are the high-level epics. That the first one is enhance the existing ONOS subsystems to accommodate segment routing applications and other applications that requires OpenFlow 1.3 features. For example, the flow rule subsystem support for multi-table awareness and pipeline support in the underlying drivers. Similarly, the second epic is introduce new subsystem to the ONOS platform to accommodate again segment routing like applications such as the group subsystem and network config management framework. And along with that, we wanted to port the segment routing application from the older development version onto this official version of ONOS and continue supporting the Dell 4810 switches for our integration testing and a possible ONS Summit demo in June 2015. Some of them I have briefly described in the previous slide, but at a concrete level, these are the high-level user stories we have created for this cardinal release. So multi-table support for flow rule subsystem, the group subsystem, network configuration management framework, and few of the segment routing application stories like default routing handling and recovery, default group handling and recovery, policy-based routing support, and policy group handling and recovery. Along with that, we wanted to have a CLI support for troubleshooting and debugging and the GUI support. Moving on, we greatly appreciate any help from the community, and we have identified these high-level 3 areas where community can be involved and contributed. So the policy is one area where currently we support 3 categories of policies, that is tunnel flow, load balancing, and avoid. Here the community can help us to define new policies or enhance the existing policies. So this is one high-level area. And the CLI support, today on the older version, we had a CLI from a different project. So we wanted to have some discussions on how we can build a CLI, either reuse of the existing one or a new one. Similarly, support for the GUI. Again, the team here is open for any discussions on any of these areas, and we can have meetings and discussions as and when needed. And lastly, these are the contacts. If you want more details, you can write to any of us, or you can refer to the wiki. And the resources section captures the wiki links. The first one is the old information, that is the old segment routing on the older version of the ONOS, and the current design proposals and all are captured in the second link. And the Jira stories are in that link, ONOS project Jira. Yeah, that's all I have. Any questions?
So any questions from the folks dialed in? We do have time, so we have probably about maybe 15 minutes. So feel free to ask any questions on the use case. It's a good time to get inputs from the folks who've been implementing it. So if we have no questions, then we'll move on to the next use case, which is essentially network function as a service. So let me call Larry here. So while Larry comes on board to give his set of slides on network function as a service, I just wanted to have Bill Snow, VP Engineering, introduce Larry.
So Larry has, here's Larry, come on in, Larry. Yeah. So very distinguished guy. He's our chief architect, and he's a professor emeritus at Princeton as well, and has been behind the work at ON.Lab, which is now evolved into Open Cloud, very interesting project. And so Larry's with us now. I'll go ahead and let him get started.
Yeah, so this is a reframing of network function as a service. You can see the name Central Office re-architected as a data center. Okay. So since I have limited time, I'm just going to jump into the target of what we're trying to do.
If you want to take some extra time, we do have 5 minutes extra, so feel free to use them.
Well, I've hidden all the other interesting slides, so I'll have to jump right in.
Okay.
So central offices are the term we're going to use for at the edge of the operator network. This could be close to the edge. It could be an honest-to-goodness central office. It could be a bit back upstream in routing centers or other points of presence. But it's where a carrier or an operator would have today a lot of special purpose equipment, hardware appliances for various purposes. It's the point at which you're basically bringing in all the subscriber connections and connecting it into the operator backbone. Where instead of filling that building full of hardware appliances, we're going to make a shift to commodity servers, commodity switches, commodity storage, and we're focused on the control plane and management plane for that environment for the purpose of building out services on behalf of different user communities or customer bases, whether they be wireless, enterprise, or residential. So this is just a graphic talking about, it's really the composition of a set of services that we offer enterprise customers. It might be the composition of a different set of services for residential customers and so on. At this point, we don't have too much precision and lock in on the services. We have a demonstration set that I'll get to a little bit later, but that's for illustrative purposes. It's not trying to be constraining in any way. So what we're focused on is building out the purple box, which I'll get into some details in a minute. So I said it's a reframing of network function as a service. We had used network function virtualization as the anchor point for trying to describe this use case. But it turns out that we had a very broad notion of what network functions were, and the community that's focused on this through various open source projects and standardization processes have a much more narrow definition. And so we were effectively trying to hijack NFV and make it something bigger than it is. And we decided to turn that on its head, talk about the bigger thing of which NFV is a subcase. What this is really about is bringing three independent technologies together. The cloud certainly has a lot of technology and best practices in how to scale applications, cloud applications. SDN, of course, is making the control plane programmable, and NFV is about making the data plane programmable. What we're really trying to do, again, is to bring all these together in a central office. And the way that I would explain both the challenge and the opportunity of doing that is we're trying to both leverage technology and use these technologies as a source of interesting services. So we're leveraging cloud technology to reduce CapEx and OpEx costs of this facility. Virtual machines, virtual networks, elastic scaling, all those techniques that are well understood in the data center, we're trying to apply to the central office. We have then three sources of services that we would like to bring to that environment. One are the services that are already offered in the cloud, but do it in a way that is appropriate for the edge of the network in the central office. So I refer to this as local value add to global cloud services. CDN is a great example. CDN is a global service. A lot of it runs in the data center, but pieces of it can run in the central office. And likewise for whatever your favorite list of cloud services might be. Find the value that you can add to those services with a point of presence at the edge of the network. Second is to offer control plane-based services. So instead of, again, narrowing in quickly on what is specifically a network function in this setting, clearly the ONOS and the applications that run on ONOS are another source of services, and we need to integrate those services just like the cloud services, and then the last point, the NFV services. Those tend to be very localized, carry a great NAT, WAN acceleration. These would be the more quote-unquote traditional NFV services that are running in the data plane in the central office. So it's, again, we've got three sources of services, and we're leveraging the cloud technology to make that all doable. So again, to go back to this picture, but now step through those four things a little bit more carefully. On the commodity processors, under the control of this purple box, which I'll break out in just a second, we will certainly set up virtual machines running traditional, I call it traditional, I mean, people are still trying to figure this out, but what is narrowly defined as NFV, WAN acceleration, intrusion detection, BNG. That's sort of the standard class of network, virtualized network functions that you would run in the data in the central office. Add to that a set of functions that are local anchors to global services. So parts of, and I'm putting the cache in that category, even though some people might lump cache, and we were earlier trying to lump cache with NFV. I view cache really as the local point of presence of a global service. And then, of course, all the ONOS applications, and I'm kind of lumping those together in one purple, ONOS box, but this would be VPNs and the various services that ONOS would support. But again, they're available as services, just like BNG is available as a service, or the CDN is available as a service. ONOS then is both leveraged for the sake of management of the network, the service chaining, the L2 connectivity, the subscribers, and so on. That's not a service in its own right, it's infrastructure. And it's a source of functions or services that are offered to different customers, and VPN would be the great example there. And then just, so I'm trying to just, again, distinguish between these different classes of services that you would run in the central office, and the distinction between services and infrastructure in support of those services. So the three pieces are XOS, which is the cloud operating system that you might have previously thought of as, we used in open cloud, but we sometimes overly conflate XOS, which is the software, from OpenCloud, which is the deployment. So we have XOS, which is a service management engine, OVX giving us virtual networks, and ONOS giving us this set of network applications. What we envision in the next two slides is what the demonstration will look like. This is a high-level view of the set of services. I'm using two abstractions. One is the service, which is a circle. That's a set of virtual machines deployed throughout the central office and in some cases elsewhere as well. And what looks like a switch is really a virtual network. We're using a big switch topology. So this is a high-level specification of the set of services and how they're interconnected to each other. But the important thing is this is high-level, under the covers. Every one of these circles is really a scalable service, not just a single virtual machine. That scalable service is interconnected by an OVX-based virtual network for the sake of scalability. So again, OVX comes into play under the covers there. OVX is also giving us the ability to interconnect different services for the sake of composition. So in this example, I will use OVX to connect the authentication service with BNG service.
Please mute if you just dialed in. Thank you.
Other of these virtual networks will then also run ONOS and ONOS applications. So I've just highlighted one of the virtual networks that will be running SDN-IP and effectively provide the connect the central office to the rest of the internet service. And a variant of that would be for VPN service for enterprise customers. This particular virtual network is interesting because will be used for wide area acquisition of content. OS stands for the object store. HPC is the caching service. And so that would be, unlike SDN-IP, where you're connecting to the global internet, this would be collecting to the global SDN network. You wouldn't necessarily transition out into the IP land, but you could put a remote object store, make it accessible through a virtual network. And finally, HPC is an example of a richer topology for the virtual network than just a big switch. This would actually be a caching hierarchy, again, talking to instances of that service that live elsewhere. So that's the software that we would hope to bring together. We have pretty much all of these pieces, but we've not actually brought them together in a comprehensive proof of concept. And the demonstration hardware, I just wanted to highlight that it is still connected to the larger OpenCloud, which has points of presence at many points, but because we're focusing on a particular point of presence, a central office, we have one particular blow up of that to what we think of right now as our reference implementation. It doesn't have to be exactly this hardware, but this is what we're running on today. This is, as the map indicates, located nearby. It's over at Stanford. So there's an OpenFlow top of rack switch, which gives us connectivity onto a larger OpenFlow based network. But there's also a local management network, and we have 14 16-core processors that we're running XOS and OVX on right now. I'm ONOS running in virtual on one of those virtual networks? No. Okay. So, in words, trying to tie some of this together, one of the things that XOS does is it gives us services managed as a first-class abstraction. So XOS provisions each service as a scalable set of virtual machines. OVX provides the per-service virtual networks that support scaling. And then ONOS is simply a source of other services that happen to be implemented in the control plane. So XOS supports service composition. That graph from a couple slides ago is a visualization of that. We are still working on the high-level specification. That will be something that we want to make concrete in the near future. And it effectively implies a security policy because you say who is and is not able to talk to each other through virtual network interconnection. OVX manages virtual networks according to two different orthogonal policies, one based on the topology of the virtual network associated with the service and the other based upon virtual network interconnection. And XOS manages virtual machine placement according to two different policies. There's a service-specific policy that has perhaps a global component, And then there's site-specific, which is simply about more traditional data center scheduling. You're going to simply want to optimally utilize central office resources. I don't have a roadmap. I think we're on the hook to do a demo for ONS, and like I said, we have many of these pieces. It'll mostly be an effort to pull them together and make them more real than they were in the earlier incarnation. By more real, I mean more directly taking advantage of XOS and OVX. The big open question at this point is the relationship between OVX and ONOS. I can say two things. One, the premise that we started with was that OVX ran as a network hypervisor, so it runs below ONOS, which is a network operating system, but ONOS runs in virtual network 0, which is analogous to domain 0 in a virtual machine setting. So it provides you with some core applications on behalf of all the other virtual networks. I still like that model. There's another argument, which is ONOS has not necessarily been designed for scale and reliability. And so, what's that?
OVX is not.
I'm sorry, OVX has not been Freudian slip. OVX has not been designed with paying particular attention to some of the strengths of ONOS, and we would like to find a way to leverage that. So it's still open as to whether OVX is on top of ONOS or the other way around, or some combination thereof. And hopefully we'll get a story sorted out. I mean, there can be intermediate steps that are not quite the full story that we'll probably have to go through to get to the final point. But we want to figure out what the final point is.
So we want to open this session up for questions. We have about 15 to 20 minutes for questions, and anything related to NFV or network function as a service, Larry is the person to ask those questions to. So I would highly encourage each one of you to use this opportunity. Oh, there's one here.
That was sort of addressed in your slide. It was an earlier question.
Okay.
Okay. It ought to. We haven't totally figured out how that's going to work, but it ought to.
Project, I can start. So, I mean, is service composition, Larry, is it same as like personalization of services? Can users personalize their own services based on primitives that are based on some of the NFV primitives?
I wouldn't say users, but the operator ought to be able to offer menus of pick something from column A and column B kind of setting.
Asking if you could repeat the question, Dan.
So the question was, does this support personalized services so that users could pick their own services? And our focus, in the end, yes, our focus right now is to give the operator the ability to configure. A point of detail that I did not go into is, if you break open BNG, my picture here, I actually view that as having some substructure that would be much more customizable. That's potentially leveraging the research at Berkeley, which we're going to have to figure out a way to merge that in at some point in the future. But that would be a place to get finer grain customization.
I have a question on the phone, Larry. Hi, it's Tom Onschutz.
Hi, Tom.
Hey. My question is back to one of your earlier charts where you showed or implied high-level service composition. You had those, 3 overlaid planes that showed different services being applied over the common infrastructure with the little, combining symbols between them. And I'm wondering what in the architecture composes the services in this. Is that ONOS Intense? Is it something from OVX, or is it yet a third thing from the cloud orchestration space?
It's from the cloud orchestration space. So so this is the slide I think you're talking about. But let me actually, the way that what I'm showing here as dots with, as pluses with circles around them, really takes a richer shape than that. It looks more like this. If you can see the slide changes there.
Right.
In the sense that to XOS, you would say that service BNG is composed with service URL filter, and it would be, you would specify at a slightly lower level than how the virtual networks, what virtual networks of those two services were allowed to interconnect.
Yeah, another hidden slide, I suppose, where you show service composition in terms of a set of VMs interconnected. So that may be, so it does leverage XOS, but it also leverage OVX and to do that, right? Yeah, this is the one I'm talking about.
Yeah. So the specification is through XOS. The actual implementation at the lowest level is the interconnection of two different virtual networks, which OVX does.
Okay.
And yeah, I mean, it was in words, and there were a lot of them. But this slide talks about which component is responsible for what something. And so somewhere in here, OVX is responsible for virtual network interconnection, which is part of the implementation of service composition, which is the second bullet.
I guess the thing that sort of sparked my question is in the chart that you then morphed to, the one, gosh, I think it's chart number 23, right, with the with all of the little elements on it. That doesn't look too dissimilar from what the network graph might give you in ONOS, except that it has added some entities that you might not have found on a network graph. And maybe there's also a higher level of abstraction of what kind of network is being provided. But it seems like there's still a relationship there, and I'm not sure exactly what to make of that.
Yeah, I think that's part of this open question, at least in my mind, which is we had been pursuing this with OVX as our cornerstone networking infrastructure, and ONOS as merely a provider of services. And I think what we're attempting to do now, and we don't have the answer, is find a deeper interconnection between ONOS and this story.
Yep, I think if this were a story that I had heard around ONOS and intents, then my expectation would have been that disruptors in that topology would have gotten repaired by ONOS as sort of a daemon activity, right? If the intent is no longer being met, it's going to find a new way to execute it. But I'm not seeing that similar kind of activity happen from typical orchestration approaches. And I'm wondering, is that something that you've developed or you've forgone at this point, or is that just something that might be worth talking about in future?
So I think the answer to your question is the assumption is that these virtual networks, the boxes, the squares on this picture, because they're OVX implemented, I specify a topology, and OVX, that is my intent, OVX repairs as necessary. If the topology I specified was isomorphic to the physical topology, then there would be no repair that OVX could do, and it would be the responsibility of the network OS running on top of OVX to do those repairs.
Okay.
So it's an open variable as to how much you shift responsibility in that model between OVX and ONOS, if you, under the assumption ONOS run on top of OVX.
Indeed. Okay. Sounds good.
So if I ask for a big switch, OVX will work hard to keep that big switch abstraction in the presence of failures underneath.
Perhaps a dumb question, or maybe we could talk after that. So, is the industry missing a proper discovery mechanism for what services are right now enabled or disabled or changed to do that, or representations of that?
As I understand the question, it is about service discovery, and is that a missing piece? And my view, and please correct me if I'm wrong, is that the operator is going to be pretty well in charge of what's running here. The allocation of virtual machines to a limited set of physical processors in this edge site, and how the security policy by which they're connected, which this graph is trying to illustrate, that's under heavy operator control. So I don't see this quite that dynamic. I see this as a fairly static specification. There's a lot of variability underneath it in how it's implemented and mapped, but this is sort of the high-level spec that I would take as fairly static.
There are service degradations that happen, failures, all of that has to be built into the service.
Well, no. I mean, that's the thing is under the covers, which I'm trying to draw out with all the little annotations beside the squares and the circles. OVX is responsible for pieces of it. ONOS is responsible for pieces, and XOS is responsible for pieces. And so there's a divide and conquer going on here.
Do the VNFs exist for VNF?
Well, we have a few VNFs, and here I'm drawing a distinction between a VNF, as is somewhat traditionally argued, and a local presence of a global function, which I'm putting
which is more the cloud side.
Which is more the cloud side. Right. So URL filter is the demonstration that the NEC folks did in the previous incarnation of this. Berkeley has a primitive version of the BNG. Those would be the two big ones on here. So the NEC version of this demo also did, what was the other? I've got the URL filter.
But there are also this scaling and all that, right?
What was the function they scaled? I think
It was
URL filter.
Yeah, it was URL filter.
They have like would you talk to any commercial companies to provide VNF?
Absolutely.
Like,
Yeah.
provide you a load balancer VNF.
Well, so now, see, this is
the load balancer was also in the NEC too, right?
well, but see now, a load balancer, I would argue, is not a, and this is where semantics. That's not a VNF in the traditional sense. It is an application of an ONOS or an application of OVX, however you partition it. So some services run in the data plane, and some services run in the control plane. And from XOS's point of view, it doesn't care. There's a controller that I talk to that gets me access to that service. And from this high-level specification, I can affect the interconnection between services, between the virtual networks on which the services are built. So let me turn it around and say that the big requirement that I would have on ONOS to fit into this model is I need to be able to think about ONOS applications. I need a multi-tenant ONOS, potentially. I want applications to not be baked in at the top of ONOS. I need them to be completely standalone, separate things. So I could implement the load balancing application as distinct from the SDN-IP application, as distinct from the maintain a caching hierarchy application, and so on. And I don't quite have a sense of how to factor that in just yet. When I had this picture up, I had 3 purple ONOS boxes, but you could think of those as a part of that. So maybe it's really 8 virtual machines running ONOS, 3 of them running instances of the OS for high availability, and 5 of them running applications. That's where I would want to get to. And I don't know enough about the ONOS roadmap to understand where that's coming, but I want to view ONOS applications as functions or services in this model.
Hi, Larry. This is Thomas.
Hi, Thomas.
Hey, we probably ought to have a discussion on what exactly tenant means, because I guess there could be different interpretations. And whether or not the tenant mechanism is the appropriate one, I think is something that we ought to discuss.
Absolutely. I'm hoping.
So for the benefit of those who are dialed in, we did a prototype version in December, but this is essentially a more real full-fledged form. So feel free to ping the ONOS team and Larry as well, because a lot of things are being formulated right now. They're not set in stone. And this is where we could also use your input and your help and to sort of point. So like, for instance, just picking load balancers, and I worked on them for a long time. If you want a simple load balancer, you could potentially put it as an app on top of ONOS, but then if you really want like an application delivery controller with all the bells and whistles, it could be a VNF. And I mean, for instance, even the role of ONOS in that case, like it sort of veers between managing the infrastructure to being a provider of apps to something else. And then again, this coexistence between ONOS, OVX, and then sharing the responsibility. So a lot of areas where we could essentially use input from the community. And if you have VNFs that you'd like to contribute, or if there are places we could do POCs and lab trials of this use case, we'd love to have your help as well.
So you couldn't see, but I was vigorously shaking my head yes.
Would you consider GI LAN services as part of VNF as well? So these are cellular network services.
Yeah.
All the IMS, blah, blah, blah.
Yeah, absolutely.
And is anyone aware of these things as VMs, or do they only come as plans?
Are these?
Oh, there are vendors that are wanting to do this. That's a very active area of NFV work. And there are next generations of that. If you are paying attention to Sachin's work at Stanford, so he's thinking about building some of those functions as well. So I think there's a whole spectrum there. And we should pay attention to that, I think, because that is where there is a lot of action and usefulness of it.
Yeah, so the one thing I want to add it here is for the GILMs, we have the use case doing this. So we were thinking the functionalities could be a software running up the appliance, which is the independent and transparent to the chaining here. That's all the chain here. There, I have a question. So the preferred deployment models is use the ONOS to the OVX to network, and the ONOS manages that virtual network.
Yeah.
Okay. So it's good. So so the question here is, in these models, do we need another to manage and control the physical?
Well, that's the question I don't have a good sense of the answer to yet. And Mark and Ali here can correct me, but my understanding is OVX wants to manage the physical network. It thinks it manages. It may not manage it as well as ONOS because it hasn't been scale and all of those things.
Yes,
that is
okay.
Currently, OVX manages it.
You want to control everything?
I'm not saying currently.
Yeah, so I think
Currently.
there is a current implementation, just to add to that, is a current implementation, but then there is also, I think we haven't taken a closer look at ONOS to see if it can bring in its resilience and performance and then take away some of the functions or maybe interact more closely with OVX, and then together they do a better job than what they're doing today.
So you could view OVX as a network virtualization app that ran on top of ONOS.
So currently, what's happening today, OVX is managing the physical network and exposing the virtual network. Right? What will potentially happen in the future is OVX will be implemented in ONOS in some way. Right? We're not sure whether it goes as a provider in ONOS or as a core module in ONOS or as an application in ONOS. We need to check the pros and cons of each, because depending on where you put it, you get advantages. If you put them else, you get disadvantages. That's the current. That's the plan. Okay. That's the plan.
I mean, when ONOS runs on Internet 2 today, it runs on top of OVX.
Right.
So that it is a hypervisor. I think we want to not give up the freedom to run other operating systems on top of OVX. That is a value that it provides. You might want a very minimal OS on your network. It's not unlike having a built-in real-time app running on your hardware. All I want to do is load balancing for this thing. I don't need a full bore operating system. I know how to do it perfectly well if I can get access to flow rules for my virtual network.
So other things is I'm thinking for data models for the virtual each ONOS the clusters to manage and control the one virtual networks. So in the central office, do you have any numbers of how many virtual networks they're supposed to be created over there? If it's large numbers, so potentially I could see some applications they want to talk each other across the virtual network. If we use these virtual controllers to manage just one of the virtual network, if such kind of service need to cross different virtual networks, I'm thinking if potentially could be scalability issues or something. How do you consider this?
The way that the question has to do with how many virtual networks would there be in a central office, and does it scale, and can it scale? And it's a good question. And when you get to the earlier question about per user customization, you could imagine a virtual network per subscriber. That's pretty extreme. The way that we're modeling it so far is it's a modest number of virtual networks, some constant times the number of services. So if I got a service, I might need a virtual network to scale it internally. I might need a virtual network that I manage it through. I might need a virtual network that connects me to a couple of other services I can connect to. But that's four times the number of services. It's not a function of the number of users. I mean, there is another issue here, which is you wouldn't want to have 1,000 virtual networks and run 1,000 instances of ONOS.
Well,
each probably.
So actually, as you already realized, I mean, this is one of our hot favorite use cases because we all have a bunch of different opinions. And it's probably one where we can make use of the best of breed from each of the different offerings from ON.Lab and outside. So feel free to contact Larry. I mean, we'd love to run this by some of the real world scenarios you have and then make sure that what we are designing actually solves a real use case. So with that, what I want to do is essentially just stop. We stop for 10 minutes. We have a break from 11:40 to 11:50 a.m. So we are right on time. And then we'll again join back in at 11:50 a.m. with part 2 of the use cases. So see you soon in 10 minutes. Sunil, yeah, I just put the slide deck up there.
Okay, thanks, Prajakta, and thank you everyone for participating in today's meeting. I'll just take a couple minutes, introduce myself, since, as Prajakta mentioned, I'm probably one of the newer participants in this overall effort. So I'm a network architect working. I've been working with DirecTV for almost 6 years now, primarily focusing on some of the video backhaul networking applications as well as on the cloud front. And as as many of the other participants have mentioned, DirecTV is interested in looking at SDN and NFV for some of our upcoming network transformation initiatives, and we wanted to kind of reach out and work with some of the open source communities such as ONOS to see how we can leverage some of the work that has been done, as well as how we can contribute to ONOS. So one of the first use cases that we have identified that we are really interested in seeing how, as in generally speaking, and how ONOS can really help us implement is the use of IP multicast. And as mentioned on the slide, the use case really is to have IP multicast working in a more of a hybrid network, and hybrid by hybrid, what we mean is SDN and also legacy. And legacy in this context really means your classical layer 3 network topology that exists today. So from a configuration point of view, here are some of the, I would say, sub use cases that have been identified that would require a certain level of effort in terms of implementation. So the use cases that we have is primarily three use cases where you have multicast sources that are behind an SDN network. And we have a topology on the next slide where we'll go a little more detail into each of them. But at the very high level, we have multicast sources that are behind SDN network, but then there are multicast receivers that are behind the legacy network. The second use case, which is the second bullet point, is you have your multicast sources behind legacy network, but you have receivers behind SDN network. And then finally, I think this is probably the end goal, I guess, is to have both sources and receivers behind SDN networks. So having a use case number 1 and 2 would really help us get to the use case 3 eventually. So Prajakta, I think I have some animation here. So if you want to, or let me take a minute to kind of describe the current network. So before SDN, this is how a traditional multicast network would generally look like, where you have the core of the network that is IP multicast enabled, and then you have various senders that are at the edges of the network, and you also have receivers that are interested in joining one or more of those multicast flows, also sitting somewhere at the edges of the network. And then from a migration, or if we were to introduce SDN in this particular network, especially at the edges, because which is where I think some of the growth would come in, we would typically either replace some of the edges of the network with SDN open flow switches. And Prajakta, now you can go forward. So let's say we were to replace some of the edges of the network with SDN capable switches, with ONOS being the SDN controller that's managing all of the SDN switches. You have this hybrid network topology where now it has a mix of SDN and non-SDN based network. And from a flow perspective, what would happen is, and Prajakta, you can do a few more clicks. I think that would enable all of the different flows that we want to talk about. Okay, so from a flow perspective, you can have many combinations here where you have your senders sitting behind the SDN network. Those are the green switches. And you have receivers that are either sitting behind SDN switches or could also be behind legacy network. And they both could be interested in receiving a particular flow. You could have a second combination where you have your sender behind a legacy network, but then you have your receivers, again, could be either behind SDN network or could be behind legacy network. And then finally, the third use case is both senders and receivers behind SDN network. One thing to note is the core of the network would still, in this particular scenario at least, is IP multicast capable, but it's also what we would call a legacy, layer 3 topology. So it's not really aware of SDN at this point. Any questions so far before we move on?
Yeah, is the IP multicast network fair to say it's a WAN network? The core network?
Yeah.
Wide area. Yeah. You're assuming geographical scale, right?
Do you want to come close and ask your question?
Sorry, the question is the IP multicast network, the core network that you've shown, is assumed to be geographical scale?
Yes, in this particular case, we would like to support configuration where the core network is, geographically dispersed across many points of presence.
Okay, thanks.
Any other questions from
I have
those
a quick
dialed in?
question.
Go ahead.
Can you hear me? Christian Chow from Huawei. Yeah, is this for
yes.
live linear traffic? Is it only for live linear traffic, or are you considering any other use case in terms of video?
So I think for us, definitely live linear is of interest. Although from an implementation design point of view, the way we should ideally look at implementing multicast would be, across. It should be transparent to the kind of traffic or application that might use this. So yes, video is definitely of interest, but not to say that this cannot be used for voice or any other applications that require multicast.
Any other questions? Sunil, I think you can get started.
So I think if you can move on to the next slide. So here are we, as Prajakta mentioned, this is kind of a new use case that we haven't really had a lot of discussion on. We have definitely had one or two sessions with some of the architects at ON.Lab and ONOS to kind of understand what would it take for us to implement this use case. And clearly there's more discussions required. But here are some of the high-level goals that we are looking at from a May release point of view. So support for multicast, including PIM, SSM, and IGMP. And I think, again, there's two predominant flavors of IGMP that may be in use today, V2 and V3. And we can, we'll hash out if we need to include both. At the minimum, we would like to see IGMP V3 being included in the May release. But that's something we will hash out. Controller capabilities to receive and interpret IGMP join requests from the receivers. So if this is a use case where you have receivers sitting behind the SDN network, and what capabilities do we need to implement in the controller to make it work end to end, where your sources may or may not be behind an SDN network. And then lastly, the controller capabilities to install multicast flows depending upon active join requests by the receivers. And let me elaborate a little bit on this one. So the way today multicast would work is at the first hop, when the sender starts to send out a multicast flow, your traditional layer 3 first hop router would either forward that flow if there are interested receivers and if there's a multicast tree already established, or would actually drop that flow if there's no interested receivers. So ideally, we would like to preserve that kind of behavior where if there's no interested receivers, we may not want to install that flow in the open flow switches. And if there are interested receivers, then we would do the opposite, where we now actually install the flows and mark them as for forwarding. So that was on the slide. And any questions?
Yes. Are you looking to do this work on hardware?
So when you say hardware, you mean on the data plane side, on the open flow switches?
Yes, that's what I meant by the May release.
Okay. Yeah, we would. And again, some of the other members feel free to chime in, but we would like to see this working with the hardware switches.
Why do you ask?
Just curious.
Okay. So I think they also have an upgrade cycle that kicks in, and it's a really good opportunity for them to bring in some of the newer things like looking at white boxes and other open source switches. Any other questions? Otherwise, we'll move to the next slide.
Okay. From a community contribution point of view, I think as we discussed, we are very early in this use case in terms of still hashing out some of the requirements as well as how the design might look like, leveraging ONOS. So I would say, we really would like to see contribution from across all aspects, be it contribution, and if people have experience implementing multicast, and if they have some contribution to be made on the design aspect of this. Certainly we can have more discussions once we have had some aspect of design and development done. We would, it'll be good to see how we can actually implement this and also roll this out in limited POC type environments from a testing, troubleshooting, and potentially, the deployment perspective in the future. And lastly, feel free to reach out to any of us. I have my email address there, and I'm certainly, willing to spend a lot of time getting this use case to work in ONOS. But at the same time, I've had some really great start and some discussions with both Pavlin and Jono, who are, who understand the overall requirements. And so feel free to reach out to any of us, and we can certainly have more discussions in the near future on this.
Sunil, this is Chanchal from Huawei again. I was wondering why you would do it this way with ONOS. Why not build apps for the SDN controller?
Yeah, so that's a great question, and that's actually been discussed right now in terms of how exactly we might implement something like this. So I think what we should do is maybe take this offline unless Pavlin or Jono have something to add here. And definitely, I think at this point we we should talk through all possible ways to implement this with leveraging ONOS, but also leveraging the northbound ONOS apps for us.
So I think Pavlin would like to add. Pavlin, do you want to add?
Yes, something very quick because it can be very technical discussion. We can do it either way, and we had some initial discussion when we start talking about this use case. Yes, we could be either transparent and let the routers do the IGP query, so we can generate them ourselves. This is to be decided. And we may end up doing both. Depends on the deployment scenario.
There's one more. So Sunil and Pavlin, there's one more question from Larkin. Says which device would send the multicast queries on the SDN side? Okay, this and who was the, no, there was the person who was calling with somebody else, or maybe it's the same. Okay. Different
Thank you.
Right. Okay. So any other questions?
I didn't understand Chanchal's question about whether this would just be an answer on top, or maybe you could try to rephrase it.
I think Pavlin understands because they went through both.
Pavlin answered that one or this one?
No, he answered that one. This one I think is a different one, Pavlin. It's sort of related. So the one you the one that was voiced was what you answered, and then the one that's text is unanswered.
Oh no, I was answering this one.
Okay, so I think you need. So okay, let me ask. Are there any unanswered questions? Just ask them again, and then we are happy to answer them. Because we are not entirely sure which ones we answered and which ones we didn't. Okay. So I think one thing I wanted to point out about this use case, and Sunil alluded to it in the beginning. So they have an upgrade cycle coming up at DirecTV, and they're using it as a really good opportunity to bring in innovations such as white boxes. They're looking at some of the newer vendors, and I think that's something interesting for everybody to consider. And I would highly recommend pinging Sunil or any of the team here if you would like to get involved with this use case. So any other questions, folks? Otherwise, go on to the next use case. Okay. Thanks, Sunil. Thanks for dialing in.
Yeah, thank you all. Thanks, Prajakta.
So we move on to our next use case. This is essentially another interesting way to develop a use case for ONOS. So this was developed by Huawei outside of the ONOS standard development team, and it was developed by an offshore team of engineers. And we will be pulling this, they're contributing it back to the community, so we will be pulling it back in the Cardinal release. So I'll let Patrick from Huawei talk more about it.
Thanks. Thank you. Project. My name is Patrick Lee. It's from Huawei. I'm going to give the presentation about this use case. So the IP run is how to the next. So the IP run is a use case is basically they cover a lot of things. So in our phase ones, we focus on the layer 3 VPNs. So here is the current status we have been achieved. So first step we focus on the POCs of doing this layer 3 VPNs. To the number one thing, so we'll do the integrate our SNC in-house field controllers with the ONOS. So we also use the outside the path calculation engines to calculate the path and work with the ONOS. So the third thing, so we present service data models. Basically, is the layer 3 VPNs, which also support load balance. The fourth part is the northbound flow API extensions. Basically, you know, the ONOS haven't support the MPLS tunnel yet. So we build the MPLS tunnels in our applications. So for the service part, we extend this flow rule APIs to install the service into the ONOS, through the ONOS to the hardwares. The fifth bullet is the southbound providers to support the Huawei's device. Here's the current status. So we're ready for the code reviews of this flow rule extensions.
Is anybody out there?
Yes.
I am here, but it looks like we lost the room.
I am here, but it looks like we lost the room. We lost Menlo Park.
Okay.
Can you folks hear us now? If somebody can just type something in chat saying you can hear us, we get started.
Yep, I can hear you, Projecta.
Okay, great. Thank you, Tom.
Okay, so I'm not sure where the call was dropped, so I just go back a little bit to repeat what I said. Okay, sorry. So take a longer time, but I will take the more questions offline if you need. Can we just just give a quick give a quick update about this one. Its current status. The current status is we focused on the POCs on the layer 3 VPNs. we already run the demos on the ONOS Summit 2014. So the current status is we already integrated the use case layer 3 VPN use case. We integrate with our in-house build controllers. So in these architectures, we move the path calculation engines to the applications. The service modeling, the data model, which we implement the layer 3 VPN and load balancers. Another thing is, the current we don't support the MPLS the tunnels in the ONOS. So some MPLS network provisioning work is done by the applications. So the idea for us is use the flow rule. We extend this flow rule APIs to install all those MPLS network provisioning and the layer 3 VPN. So later on, once the ONOS support the MPLS tunnels, we are split it apart. We are called the internet APIs for the network. So the fifth bullet we implement is a southbound providers. Basically, it's support the Huawei's device. Protocols is we basically is build the agent between the agent and the outside box is I have some slides I can show you later on. So for the May release, we're going to do the following things to team up with the ONOS teams and the others who want to contribute on these ones. So the first one is the service data installations, which is we think we might need to add more extensions here. So another thing is the MPLS label service and the management. Here is another thing is we want the ONOS to manage the MPLS labels. Currently, so we are seeing a couple of use cases as require these ones. One is the segment routing, which require allocate the global labels. So for us is allocate the local labels. So the ONOS probably is the best place to manage these ones. So we need the central management, the managers to manage and the MPLS labels. So another one is when we deploy, when we implement these ones, we found one case is called the broadcast network topology support. So we found in such a LAN environment, so the RRD DPs will create multiple links. So in the ISIS, they basically learn the topologies and add the insert a virtual node. And so when the southbound the providers to indicate this one to the ONOS cores basically will show that virtual node, which will cause some confusions in the topologies. So we want to enhance these ones. It's the third one. The fourth one is because we're doing the protocols in the applications. Application is sitting on top of this the ONOS is running outside. What I mean is running out. Okay. So the packet in and out, we require the ONOS to provide the packet in and out APIs to allow the applications to transmit and receive the packet, control packet. So the fifth one is the MPLS tunnels. We want this one, the MPLS tunnel provisioning APIs from the internet network. APIs, internet APIs, sorry. So the priorities is from the top to the bottom. Any questions so far?
Can you put this up right before one question? So I think there's a question.
Was the remove the fact that
Okay, looks like Thomas answered that one. So. Okay, you can move on. I think Thomas.
Okay, what's the question? Should I answer this question? Okay, I'll take care of this offline. So if I miss too much of the information there. Okay, so any questions specific to this requirement? Basically, I also saw the MPLS town node management is required by the other use case. So I hope the ONOS the new release will form a Tiger teams or something to work on this one, to generate the common structures to meet all these requirements.
Can you give an example of service data?
So the data is R3 VPNs, right?
Okay. Yeah. But what do you mean by installation of service data?
The installation is something that do you have the slide I attached to? It's the one is the producer general. Huh? The play. So we were thinking eventually when you support the R3 VPNs, basically you need two steps. The one is you provision the network to build up the tunnel. Okay, what we call is the network of provision. It's producers. So later on, after you finish completing your provisional network, you install your service, pseudo-wire and the layer 3 VPNs on edge. So the service is installed on edge, or some potential service point. Okay. So we split this ones into the two separate the applications. One is we call the producers, and another is called the consumers. So we recommend this model to be implemented by the ONOS. Basically, another reason we prefer this model is the producers were just a provisional network, and later on when you add and remove the service, so the network should not be re-provisioned and keep the network stable. So all these ones, installation, the service, and produce the network is separate. So what I mean is the second thing. So I also have more slides attached to this presentation. So if you have any questions, you can read the slides. If you have any questions, send me email. Okay, so basically, we prefer these 4 bullets to be addressed and covered by the ONOS development communities. So I saw that it's not only this layer 3 VPN requirement, some requirements is pretty much common. I think let me see, the packet in and out, and I'm sure knows all these ones is pretty common. So
Packaging, packet out service is not supporting the packet service today. The subsystem we have in the
okay, here, so what we require. Okay, so can you go to the backup?
What do you want?
The backup slides for the answer the questions, the packaging in and out.
Yeah, which one do you want?
Which one is let me see. Come down here. Here's the next step about this one. Yes. Okay. So actually it's a kind of deep dive in how to implement this one. So basically we talked to the Thomas and the TST the teams before. So about this, how to support this the packet in and out. So here is what we means. ONOS need support. Okay, the applications basically is running outside of the ONOS. So the couple of things I want to catch your attention as the ONOS provide the distributed cores they only take care. They have the channels to take care of the control packet from the switch they managed. Okay, so the applications is only talked to one instance. Think about this once. If your packet, the equipment is managed by the other instance, what are you going to do? You are going to do as the ONOS instance basically need to forward that packet to this applications. So the traffic is what I mean. So the current implementations is they only support the packet. Correct me if I'm wrong. There's anyone who implement this ONOS packet managers. So currently the packet is only taken care by the ONOS. They won't send it out to the outside the applications. It's what I learned, right?
No.
No,
you forward the packet from the data plane through the core to the application.
Yes. No. The application is running inside of the instance.
It's over rest. Doesn't go over rest.
Yeah.
No rest.
Yeah.
That would make real loud. Really loud. Yeah. Right. No, we don't do that.
Yes, it's a thing. But once your protocol is running in the application, it's running outside of the ONOS. Basically, we believe that some channels need to be provided.
You can provide your own channel.
It's not okay. It's the problem is this. If we provide the channels, we don't know which switch we are going to need to connect to. If the network has the thousand guys, switches will generate control packet. So if the applications is running outside, we need to talk to each flows by the applications, right?
So I think there's 2 points here. The first point is that currently, in order to register for packetings, you have to be running on the same instance that is master for that switch.
You don't have to.
No.
You can get them. The short service. I think his point is.
Well, his point is filtering. So that's the second part, which is the ability to filter which packets are received by each application and not have them receive the whole stream.
Yes. So actually, I sent the Thomas and Ali on the slide before. Basically, we were thinking it's for the captures. So the traffic has to be in and out. For the out, no problem. For the in, basically,
Thomas.
Okay. I answered some of those questions in a text. This is a deliberate design decision. So if an application wants to run special processing only on selected instance or run it somewhere off platform, then it's its responsibility to deliver the packet where it needs to go. The core delivery mechanism, we decided specifically for performance reasons that we would not be leaving not only the VM, but we would not even be leaving the I/O thread. So all of the packets are processed on the same I/O thread. This is purely for performance reasons and for simplicity.
Well, I think talk about this offline. So basically, so the applications is building the intelligence in the futures. Every people want to try something new. So basically you cannot ask the applications, each application to build the connections between the switch and the application. And here's my point. So the ONOS as a platform or potential the controllers, basically you need to provide something to hide these ones, to provide the common APIs to applications to send and receive the packet.
Yeah, but if you're a Java application, you can. If you're a REST application, I mean, you just lose you lose all your performance, you lose everything.
So I think, Patrick, if we can follow up with the meeting,
yes,
I think you can sync up with Thomas and the team.
Of course, so we talk about this many times. Basically, you exposure the network functionality to the application. Application will build in the intelligence, so that you can ask each application to talk to the switch underneath hardware. it's an argument. Yeah.
Yeah. So feel free to think up with them. And
yes. Yes. Understand. Okay. So the basically here is the things we want to team up with the ONOS teams to get this done. It's a lot of yeah. It's not just the coding work.
Yeah. Yeah.
Okay. So any questions? Contact me. Send me emails and the project. So.
Thanks, Patrick. And if you'd like to again contribute to this use case, learn more about it, chime in on some of the technical discussions, feel free to either ping Patrick or Thomas, and they'll include in all the discussions that happen. So we're going to take a quick 10-minute break so people here can just grab the pizza that's getting cold, and we'll sync up back at 1:05. So we have a last session, and then Bill will conclude the session. Also, if Tom Anschutz and Sato-san would like to chime in, it would be great to hear if you have anything to say. VP of Engineering here at ON.Lab. So with that, Will, do you want to get started?
Yes.
Maybe, yeah.
Okay. Hello, everyone. So, good afternoon. So, my name is Vivi from Huawei. So, this is another use case from Huawei. So, it's about the IP optical SDN control. We try to integrate PCEP with ONOS, so we can unify control the IP optical network. So, okay.
Oh, because, sorry.
So basically,
It's probably crashing. This one?
Okay.
It doesn't like the slide. Sorry. Okay, let me try with this. Okay. Let's try it through again. Something strange about it. Yeah.
Can you present?
You want to present like this?
Yeah, maybe it's
okay. Let's try it again.
Okay. So, Huawei's IP optical solution is based on the PCEP. So I think it's essentially the evolutionary approach for the service provider network. So currently PCEP is a very popular in service provider network. So honestly, the SDN controls the platform which we come with. So how can we integrate the PCEP in the southbound and with the ONOS in the core, and we develop some of the multi-layer PCE in the northbound. So in our architecture, so we have three kind of components. In the northbound, we develop some of the multi-layer PCE, leverage the global topology provided by ONOS for end-to-end optimize the TSP computation. So we consider a lot of the policies and the service provider requirements. So it's northbound, we develop the multi-layer PCE. So in the core, we integrated the ONOS distributed core. So take advantages like the global database and the high HA properties. So, so the most I think is a specific part is in southbound. We use the PCEP, RGP, the protocols for multi-layer topology auto discovery to support the commercial Huawei IP optical equipment. That's so base three kind of things in our solution for PCEP based IP optical control. So we have done a lot of things since last year. So we have developed the multi-layer PCE in the northbound. We work together with the IP team. So on the internal northbound, southbound software agent inside ONOS. So we extend some northbound ONOS API to support the PCEP solutions. Also, we intend the current intended framework to support TESP in the context of the PCE architecture. In the southbound, Huawei has a PCEP RGP the protocol component, but it was written in a C++ code, so we developed some agent to talk to the southbound provider. So right now, so we are under the integration and the system test for the test bed. The test bed is 40 nodes, including the IP routers and the optic switches from Huawei. So we have three kind of stories to present IP optical convergence. So the first story is based on the topologies on demand, which means so we can dynamically create IP topologies for the service. So create a tunnel for the like the layer 3 VPN, layer 2 VPN, something kind of. So traditionally we created the IP topology static. So we plan in IP topology and the design it take a long time. So but Huawei IP optical solutions can dynamically create IP topology. So we call it topology on demand. So second one is the binary on demand. For the data center, maybe the interconnection. So when the two routers binaries is not enough, we can dynamically provision optical binaries to support such kind of things. So the third one is multi-layer recovery for the IP optical networks. So I will show the details in later. So in the main release, we are going to contribute back to the ONOS in terms of the 4 aspects. The first one is we are going to contribute like in southbound and northbound API architecture for dedicated for the PCEP support in ONOS. We also developed a new kind of intent for PCEP. PCEP based on the MPS concept, so it has the T RSP. So we based on current intent framework, we develop a new kind of intent support of PCP. So the third one is about we are going to present some good solution for the RSP. Is basically a tunnel event notification mechanism in the PCEP architecture. So once in the network the RSP tunnel, we call tunnel, the status was changed, so happy notify the multi-layer PCE. So right now we integrate the ONOS in the call, so we have to tell once the RSP status changes, we have to tell the ONOS call. So ONOS call notifies the application in multi-layer PCE in the northbound. So right now, so ONOS call doesn't support such kind of notification. So we are going to support come up with some new solutions for such a thing. So the last one is pack in, pack out. So the package is from talk a little about. So we just reuse the kind of asset concept from IP run use case.
PCEP is a more protocol. Why are we bringing it to the higher layers of the ONOS? Should be only the provider layer.
Yeah, the top bomb is a PCEP.
David, can you repeat?
Okay. So the question is the PCP is the protocol is mainly work on the southbound, so it's provided. So why we need the PCP? Yeah. So PCP is we use the PCP as a provider in southbound. We leverage ONOS in the core for the distributed database like something like that. Although also we develop some of the multi-layer PCE optimization like path calculation in the application layer. That's the whole architecture of our IP optical solutions.
That's your question. You are saying that the PC.
Let me.
Shrikant, you want to?
However, people can hear you online.
Yeah, you can.
This might be useful for people to know.
No, at least my understanding of PCEP is more like a protocol piece where it should sit in the provider layer, but seems like we are trying to bring that awareness into the intent layer and the northbound also. That's the primary question that I have. But you are saying that the PCE module itself is PCEP aware?
PCEP is a kind of communication protocol between the PCE is a path calculation the component, and the PCC like the path control the switch, something like that. So that defines some communication protocol between the two modules.
I think you have a slide, right?
Oh yeah.
You have a slide. You can show how does the component need to work with each other.
Okay. Yeah. Yeah. Basically, so you can see, so in the provider layer, so we have some the OCPF IGP, also the PCEP in the southbound. So we some agent developers we use the RP-REST use case. So we have southbound API. We are going to expand the southbound API to support the PCEP. So you can understand. So we have some the ONOS call. We integrate the ONOS call in the solution. So we also have some northbound the API extension. So most of the important part for the PCE is a multi-layer PCE in terms of the application layer. So it's take a more most intelligent the part of the networks. So it's you're right. So with the PCEP work as you can see next one. So it's another use case. So we have some PCEP. PCEP is for the once the multi-layer PCE components calculate the path, then we notify the we call it the head end node is the source node path. That just let the head end node path know the path. They automatically establish a path for the service. So the multi-layer PCE calculate path and the call the intent framework and pass the intent, new kind of intent. I think it's not the intent, it's a PCEP kind of intent. And to the provider just install the intent to the first node of the path. This is the concept.
Check the chat and see if there are any questions.
Yes.
Are you here?
Yes. Yes. I think that's okay. So that's what I have today. So I have the more details in the okay. Let me go to the Okay. So actually we have some requirements from the for PCEP solutions in terms of IP opticals SDN control. So basically, so we have from the source to north. So we collect some topologies, use the ONOS call. So ONOS call carries the whole topology and send to the PCE application. We call the Huawei developed multi-layer PCEP here. So we calculated the path. So we should support the external PCE. Right now, so honestly, only has the internal PCE. We developed the external PCE. We should we also need to support in the call support the standard RSP. We call the tunnel. Maybe the TRSP request include the whole export from the call to the PCE provider. So once the PCE application calculate the path, they should not found the API to tell the honest call. So we store the RSP in the intent database and also pass the intent to the PCEP providers. So it's a wide requirement. Another requirement is that okay, right now the PCEP work in this way. So once the switch in the data plan, so responsible to detect the RSP status. Once the status changes, they should notify the PCE application. So right now we have the honestly in the call. So originally, so switch can directly talk to the PCE,
but we right now we have the ONOS in the core, so we have to come up with the solution. So once the PCP provide the adapter got a message that should notify the ONOS call, so has some event notification, and we think about it should be based on intent framework. Intent framework so can support tell the northbound application like a multi-layer PCE. So that's I think is a big difference from the other use case. So I think it's specific. So it's a special requirement. So we need some kind of things like the kernel, like the RSP, the intent. We develop a new kind of intent based on the intent for the RSP for the PCE. So once the RSP changes, status changes, we can notify the application is northbound. Right now, we didn't see some of the notification from the southbound to the northbound in the call. So that's our requirement. Okay. In terms of the intent framework.
Okay, maybe we should take the conversation out of this.
Okay. So actually, by the way, so in the ODL controllers platform, so PCEP and is included in the service provider version. They developed the kind of basic version and the enterprise version and the service provider version. In the service provider version, they include the PCEP providers. So like a PGP. So PCEP solution is very popular in the service provider network. A lot of the operators run the PCEP in the network.
Thanks. Thanks, Vivi. Okay. So thanks everyone. This was our last use case session. What we wanted to do was also now get back to the use case steering team and have a few words from Sato-san. Sato-san, would you like to just say a few words before we conclude the session? And again, thank you very much for staying awake. It's probably almost time for your coffee.
How about Tom?
Tom Anschutz, are you dialed in?
Yes, I sure am.
Okay, so let's start with you.
How about that? Sure, thank you. Well, first of all, I really had a lot of fun today going through a lot of these use cases. I think that we're bringing the bar up, or moving the ball forward, or whatever your favorite metaphor is. We're making good progress with ONOS and understanding what kinds of applications we can attack with ONOS, and sort of bringing SDN in general, I believe, forward in the industry. So it's been a really exciting day for me. I look forward to other applications and use cases and features being contributed in the months to come, and I'm really excited to be able to help in this regard, to help with the team that's leading use cases.
Thank you, Tom.
Thank you too.
So let me see if we can get Sato-san. Otherwise, we'll go to Bill. Sato-san, are you there? Would you like to say a few words?
Yes. Today so there are many use cases that very interested in very good use cases. So I hope those use cases have a success. So I hope so. Thank you.
Thank you very much. And again, we really appreciate Tom and you really taking the time to participate in the entire session and drive it. So thank you once again. With that, let me hand over to Bill.
Same for me. Appreciate you guys being there, and really glad to have a use case steering team that's getting started now. Also appreciate the use case leads today, putting together a good set of information. I think it was at the right level. I think it opened up some good discussions that need to happen on the architecture front. I know Thomas is going to start working with the technical steering team to get some discussions going in those areas. So it'll be great to see the technical steering team also get going with the community on some of these architectural issues. And I appreciate Prajakta setting this all up and getting the format and everything arranged. So would like to hear any feedback you have, good, bad, or indifferent, on these sessions. We want to keep improving them. I know it's hard to sit online for this amount of time, but if you have ideas on ways that we could make this better, please let me know or let Prajakta know. So I think with that, we'll sign off, and thanks everyone for participating today. And we've been recording this, so it'll be online pretty soon.